Probe 1, come in.
Roger, Charon. Go ahead.
You're losing your signal as you proceed deeper into the galactic mass.
There's not much we can do about that, Charon. We're going in.
Roger, Probe 1. We'll maintain communication as long as possible. Good luck, boys.
In the last 2 programs, we developed the sine and cosine laws, which allow us to solve oblique triangles. The sine law allows us to handle side-side angle, as well as situations where we know 2 angles and 1 side. The cosine law handles side angle side and side side side. To solve a triangle, first look at what we know. If we only know 2 pieces of information, like 1 angle and 1 side, then we can't solve for anything. So let's say we have at least 3 pieces of information. Now, how do we know which law to use? The key lies in opposites, knowing the value of at least 1 angle and its corresponding opposite side. With opposite information, we can apply the sine law, because that's how the sine law is structured. A over sine A, opposites, equals B over sine B, more opposites, equals C over sine C. Let's solve this triangle. We know these 2 lengths, and we want to find the third. We also know the value of this angle. Naming the triangle ABC, we see that side A is 6 units, side B is 7 units, and angle B is 51 degrees. Since we know both angle B and side B, we have opposite information. So the sine law can be used. If we work with the AB portion of the sine law, we have only 1 unknown value, angle A. It is found to be 42 degrees. Angle C is found by subtraction, 87 degrees. Finally, the BC portion of the sine law gives side C. With opposite information, the sine law works like a charm. But it's the cosine law for those situations where we do not have opposite information. In the case of side, 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 plug in the numbers and solve directly. But this only provides 1 angle. How can we find the other 2? Well, having found angle C, we now have opposite information, angle C and side C. So we could apply the sine law to find the other angles. But the cosine law can be restructured to allow us to solve directly for any of the angles. Let's say we're given the values of all 3 sides and we want to solve for angle A. We can rewrite the original cosine law equation to suit our needs. First, we put in angle A instead of angle C. Notice the cosine law always has the opposite side on the left of the equals sign, side A. The other 2 sides can be inserted either way, it doesn't matter. We know all 3 sides, so in this equation, the only unknown is cos A, and we can solve for angle A. We can rewrite the cosine law appropriately, depending on what information is required. The side of the triangle that appears to the left of the equals sign corresponds to the angle at the end of the expression.
Looks like a clearing ahead, Charlie.
Well, that's not just a clearing, Ed. It looks like a black hole. See? You can't see anything inside it. Let's figure out how big it is across.
Well, we can bounce a signal off the stellar matter at the left and right edges.
Right. Looks like they're both 1.1 parsecs.
We can also observe the angle between them from our point of view. It's 14 degrees.
Right. Now we just have to solve for the length of the third side. Any ideas?
Well, first we check for opposite information, and there isn't any, so we'll use the cosine law. Let's label the triangle PQR and rewrite the cosine law to suit this situation. We know angle P. Now the opposite side is written to the left of the equals sign. That's side P. And we just have to insert the remaining two sides. Our only unknown is side P, the distance across the black hole. A calculator gives the value of side P 0.27 parsecs. But PQR is a special triangle. With its two equal sides, we can take a slightly different approach. Isosceles triangles have equal angles opposite the equal sides. So these two angles can be found, and they're 83 degrees each. Now we have opposite information and can use the sine law to solve for side P. We can rewrite the sine law equation using P, Q, and R. Using the PQ portion of the equation, side P is the only unknown. Of course, solving this equation confirms that the value of side P is indeed 0.27 parsecs. The sine and cosine laws, along with the trigonometric ratios, give us an impressive array of tools and techniques for solving triangles.
That's a pretty big hole, eh, Charlie?
It's worse than that, Ed. We're beginning to accelerate towards it, and we can't stop. I think we may have gotten too close.
Oh my gosh, Charlie, we weren't supposed to go inside.